Hello everyone, this is River and today we are going to measure alkalinity and hardness. But before we get started, I would like to go through some of the backgrounds. So first, let's talk about carbonate system. We know that in the atmosphere, we have carbon dioxide CO2 in the atmosphere. And we also know that the natural water is in equilibrium with atmosphere. So CO2 also plays an important role in the natural water. The carbonate system involves several chemical reactions like shown here. Then let's talk about alkalinity. Alkalinity is defined as the capability of the water to neutralize the strong acids and includes such as hydroxides, carbonates, bicarbonates, and so on. In natural water, the major contribution of alkalinity is caused by hydroxide, carbonates, and bicarbonates. So if we assume only carbonate system is in the natural water, then alkalinity can be expressed by this equation. We can also define the carbonate alkalinity and bicarbonate alkalinity, and they can be calculated like shown here. In practice, alkalinity is determined by titration with strong acids such as HCl, and of course, the concentration of the strong acid is known. So, the total alkalinity of a sample solution can be calculated by this equation, and here are the assumptions. So, for more information, please read the lab protocol. Then let's talk about hardness. Hardness describes how hard the water is. Here, the hard water refers to the water that has a very high mineral content. In natural water, the most contribution of hardness is calcium ion and magnesium ion. And in practice, hardness is usually determined by titration with EDTA. Here is the chemical structure of EDTA. EDTA can form very stable complex with calcium ion or magnesium ion and some other divalent cations that can cause hardness. And here is a chemical reaction. The M plus here refers to the divalent cation. Total hardness can be determined at pH equals to 10 because at this pH, EDTA can form very stable complex with the divalent cations. Here is the chemical structure of EBT, and here is a reaction. We can see that as we add more EDTA into the solution, the reaction goes to the right direction. And then for the calcium hardness, we usually determine by titration with peroxide at pH equals to 12, because at this pH, all magnesium are precipitated. For the indicator, we use peroxide. Here is a chemical structure of peroxide, and here is a chemical reaction. We can see that as we add EDTA into the solution, the reaction goes to the right direction, and the color will change from something like pinkish into purplish. And then let's do the experiment. So now let's do the alkalinity experiment. First, we have 25 ml of samples in the beaker, and then we add 25 milliliter of DI water into the solution. Then we add several drops of phenolphthalein into our sample. We can see that the solution becomes pink. Then we measure the pH of the sample. And then when the pH gets stable, we take notes of the pH reading. And then we start and titrate with HCl. When the color becomes completely transparent, then we add mixed indicator. And then we mark up this color change point, which is around 0.5. So for now, we have all the data that we need. Um, and we can take notes on the color change points and the corresponding volume of HCl, and then we can calculate the carbonate alkalinity and bicarbonate alkalinity. So let's recall the equation that Xuan mentioned before. And based on this equation, we can plug in the numbers of our experiments data, and then we can calculate bicarbonate alkalinity and carbonate alkalinity. So this is for alkalinity. So now we are going to measure the total hardness. So here is our sample. And so first we add 25 ml of DI water into the solution. And then we measure the pH of this solution. We can see that the pH is also very basic, and then we write down this pH. And then we add ammonium buffer to the solution. And then we add EBT. Next, we titrate with EDTA. And then by having the volume that makes the color change, we can calculate the total hardness. We can use this equation to do the calculation, and then we can calculate the concentration of hardness by this equation. And that's it for total hardness. So now let's measure the calcium hardness. So first, we add 25 mL of DI water into the sample. And then we measure the pH of the solution. And then we write down the pH of our sample. Next, we add 10 milliliter of NaOH into the solution, but here I don't have enough sodium hydroxide. I use potassium hydroxide instead. And then we add the muric side indicator. Now we can titrate with EDTA. So now we have the data of the volume of calcium hardness, and also recall that we have the equation here, and then we can do the calculation. We can calculate the calcium hardness in the solution. And that's it. Thank you very much.